All right, hello and welcome to the last video for 8.1. We've been talking about simplifying radicals, both ones that simplify to whole numbers and ones that simplify to this sort of half radical, half coefficient kind of thing. We're going to continue that. What happens when you have a variable in there? So let's start with this guy right here. We have root 16 m to the third. Now when I just say root, I mean the square root, I mean the second root. So I have the second root here, right? Which means if I break up 16, if this was just the square root of 16, then I could break this up into 4 and 4 and take a 4 out. I think I'm going to go ahead and do that now. But with the m, same idea. If I did know m, I would know that I had 3 of them. 1m, 2m's, and 3m's. I don't know much more about m. That's really all I know is that I have m cubed, and therefore I have 3m's. I don't know if they're prime. I don't know if I could split them up further. I don't know if they're 0. I don't know if they're negative. I don't really know anything. So assuming, actually I do know one thing. I do know that they're a positive real number because they tell me. But I don't really know what that positive real number is. So I can't split this up anymore. Luckily, this is as far as I need to go to see if there's anything I can take out of there. I'm looking for groups of 2 here, and it looks like I do have a group of 2. And so that group of 2 m's becomes a single m outside, and I have 1 left over. So I'm basically treating the variable the same way I would treat any other number. I just can't really factor it into known items. All right, let's try that again. We'll go over here. Let's just do one piece at a time here. Let's start with the 200. We could break into, I don't know, 20 and 10, 4 and 5, 2 and 5, 2 and 2. Looks like I have a group of 2 and a group of 5s. So I've got 2 times 5. I'll leave a little space for variables over here, but I've got a leftover 2 over there. Let's talk about the k now. I have 7 k's. There we go. How many groups of 2 can I make? 1, 2, 3. So 3 k's on the outside. And 1 left over on the inside. With the p, looks like I'm going to need to move this over just a little bit. Sorry about this. I know you can't do this, so I feel bad doing it myself, but it's fine. I have 8 p's. 7, 8. How many groups 2 can I make? 1, 2, 3, 4. Whoops, 1 too many p's. And I've got 4 groups of p's, so that means I have 4 p's on the outside and none left over. Squish all that back together, you get 10k cubed. I'm going to write a real k instead of this weird broken up k. And p to the 4th. The leftovers are still on the radical. And there we go. All right, so one piece at a time, one variable at a time, one step at a time. Let's try with a cube root now. This one, remember, cube root, it's okay to have a negative under the radical, but how do you deal with that with simplifying? Here's the thing I would start with, taking out the negative altogether. That's what I recommend. If you take the negative out, you treat it as its own separate factor, you don't see it come into play over and over and over again. Negatives, negative 1 can be split into however many negative ones you need. So if I needed a group of 3, well, negative 1 times negative 1 times negative 1, that's going to equal negative 1. So there's my group of 3 negative 1s, and negative 1 gets to come on the outside. All right, but what about that 8? What can I split that into? I can split it into 4 and 2 and 2 and 2, and therefore there's a group of 3. Can bring out a 2 as well. How many x's do I have? I have 4 x's, which means I can bring 3 out as a group of 1 and leave 1 left over. Now, just in case you weren't able to follow that in your head, let me write out my 1, 2, 3, 4 x's. There's my group of 3 that became this guy right here. And there's my leftover. If you think you can separate that by taking out the groups of 3, you can do it in your head. You don't need to write down the 4 x's. Just like if you think you can take out a group of 3 y's as a single y and have 2 left over in your head, then you wouldn't need to write out the 1, 2, 3, 4, 5 y's, find the group of 3, and the leftover 2. It's up to you how you want to do that. Just make sure you count correctly. And then just a little bit of simplifying here. By putting that negative 1 and that 2 back together, we achieve our simplified radical. Cool. Let's do another one. Keep going here. We got a couple more. I recommend you try this one on your own. If you don't know what to do with the negative, that's fine. Maybe just leave that off for a second, but see if you can factor this down without the negative. I will give you 5 seconds to pause the video so you could do that. All right, hopefully you tried it out. The negative on the outside here is just a -1 coefficient, and so really at the end of the day, it's just going to turn whatever we take out to negative. For 32, we can break that into, I don't know, 4 and 8. Maybe you did 2 and 16, but after that, we should all end up getting 5 2s. Okay, no matter what, the prime factorization is unique to each number. It will not change. So no matter what path you go, we should all get 5 2s. And therefore, we have a group of 4 2s and a leftover 2. Cool. If I have 9 y's, that means I have 8 y's becoming 2 groups on the outside and a leftover y, just in case you didn't catch that. 6, 7, 8, 9. Here's my 4 and 4. There's my 2 groups and my leftover. All right, so my final answer would be -2y squared times the 4th root of 2y. Now, if your handwriting is like mine and you are worried that your 2 and your 4 are going to smush together somehow into 24, then by all means put that second thing in parentheses. It means the same thing. Your computer should be able to tell the difference, obviously. If you're very careful about it, just don't actually mix them up on, well, I don't know. Be careful in the slot too, because it's kind of hard to tell whether it's in the 4th root or the 4th power. So be careful about that. The computer will also accept parentheses, so it should be good either way.